All right, I'm going to go over your Unit 11 Test Number 2 review. As always, there is no need to watch this entire video. It's always better to, just fast forward to the ones that you're struggling with. All right, so for the first one, we have a trapezoidal prism, and we're trying to find the surface area. Well, the surface area of a prism is the perimeter of the base times the height plus 2 times the area of the base. Well, my perimeter of my base is the trapezoid. So my perimeter is 10 plus 7 plus 6 plus 8. Which is 31. And then the area of my base is the area of a trapezoid, which is half your two bases added together, and your base are always the parallel sides, so 6 and 10, times the height of your trapezoid, which is always perpendicular to the base. So that means it's 7. So half of 16 times 7 is 56. So now I can figure out my surface area, which is 31, times my height, which is right here, 13, plus 2 times the area of my base, which is 56. 31 times 13 is 403. And then 2 times 56 is 112. Then add that to 403 and you get 515. Oops. And then that's units squared since we don't have units. Find the surface area of a cone. So the surface area for this is the perimeter of your base times your slant height plus the area of your base. Now, our base is a circle, so my perimeter, my base, is really my circumference, which is 2 pi r. Oh, it's half. Sorry. Half. There we go. So 2 pi r, which, actually, let me put it up here. So, and my radius is 3. So that gives me 6 pi. This is my slant height. So this is my L. And then the area of my base is the area of a circle, so pi r squared. So pi times 3 squared, which makes the area of my base 9 pi. So my surface area is half of 6 pi times 8 plus 9 pi. So half of 6 is 3, times 8 is 24 pi, plus 9 pi, which means that it's 33 pi, or if I need my rounded answer, 33 pi is 103.67. This is surface area, so square centimeters. All right, so this is the surface area of a regular pyramid, meaning that all of the faces of those triangles are isosceles triangles. So that's why these are isosceles, because it's a regular pyramid. And it's a triangular pyramid. But surface area for a pyramid is half the perimeter of the base times the slant height plus the area of your base. All right, so if this is a regular pyramid, that also means that the base is an equilateral triangle. So if both of these are 18, this back line back here is also 18. Oopsies. So this back here is 18 yards. Because anytime that you have a regular pyramid, its base is a regular polygon, which means all the sides are the same. So if it's a triangular pyramid, then the triangle on the base is an equilateral, or a regular triangle, which is an equilateral. Okay, so the perimeter of my base is, of course, 18 plus 18 plus 18, or just 18 times 3, which is 54. The area of my base. Now, we have all the sides of this triangle. You could set it up as a regular polygon if you want, or you could use Heron's formula. It's whichever one you want to do. I chose Heron's formula, which means that my S was 18 plus 18 plus 18 divided by 2, which was 27. And then the area of my base was that terrible square root, right? This 27. And then what I did is 27 minus 18, and then I cubed it because there are 3 sides. You would have to just list that 3 times. So you don't have to cube it. You could have done this 27 minus 18 and 27 minus 18 and done all of that. I just cubed it in my calculator. So when I put it in my calculator, it didn't look like this. It looked like that, but it's the same thing. And it gave me 140.3. Well, actually it gave me a longer decimal, but we're going to say 140.3. It's really 29. And then my slant height we're going to have to find. So my slant height, oopsie, is across the side to the middle, right? And this is always a 90-degree angle. So we have a right triangle. This is 9. This is 16, which would be my hypotenuse. So we have my slant height squared plus 9 squared is equal to 16 squared. I'm going to subtract my 9 squared on both sides, which gives me 16 squared minus 9 squared, and then I need to square root to find my slant height. So the square root of 16 squared minus 9 squared, 13.2. So my surface area is half my perimeter times my slant height, and then I'm going to add in my base. So if I do just this beginning half first, we have the 13.22, and I'm going to use the unrounded answer times 54 times a half. So that gives me 357.2 plus 140.3. Then I'm going to add that to, and remember my 140.3 came from this. I actually did that on a different calculator. So let's do it on this one. Oops. (27 times 27 minus 18 cubed). So 497.5. It is always better if you round at the very, very end. You will have less mess ups. This is surface area, so it's squared. All right, find the surface area of this solid. So it's half of a sphere and the lateral surface area of a cone. It's a half sphere because remember, whenever you do the surface area of a hemisphere, you normally add in the base. So I'm going to half a sphere's surface area. So it's half of a sphere, surface area of a sphere, plus the LSA of a cone. So, half of a sphere. I know it's a hemisphere. I'm calling it a half of a sphere because we're actually going to use that formula. So a sphere's formula is 4 pi r squared. My radius is 7 divided by 2. So 4 times 7 squared divided by 2 is 98 pi. And then my LSA for my cone is half the perimeter of my base, which is the circumference, times the slant height, which we don't have. So we need the perimeter, which in other words is the circumference, which is 2 oh, actually it's just the diameter pi. So 14 pi. That's pretty easy. And then the slant height you're going to have to find. So this is my slant height. This is only 7. So we're going to do basically the same thing as last time, but now our slant height is our hypotenuse. So 7 squared plus 11 squared is equal to our slant height squared. So square root all that to get your slant height. Oh no, where did it go? Okay. Square root of 7 squared plus 11 squared. 13.03. All right, so now we can find the LSA of the cone. So it's half my perimeter, which was 14 pi, times my slant height, which was the 13.0. So times 14 times a half gives me this terrible thing, 91.3 pi. So then I add them together. So I need to add this to 98, which makes it 189.3 pi, or 594.6 centimeters squared. Find the lateral area of a cone if the height is 12 and the slant height is 16. So we have a cone. And we know that this height here is 12 and that the slant height is 16. But we also need to know this radius because we don't know it. So we're going to have to do Pythagorean theorem to find the radius. So my radius squared plus 12 squared is equal to 16 squared. I'm going to subtract 12 squared on both sides, which makes it 16 squared minus 12 squared. And then I'm going to square root it to actually find my radius. That gives me 10.6. So my LSA for my cone is half the perimeter of my base times my slant height. So the perimeter of my base, we have not done that yet, which is the circumference. So 2 pi r is 10.6. So times 2 means that my radius is 21, I'm sorry, not my radius, my circumference is 21.2 pi. All right, so my surface area, lateral surface area, is half of 21.2 pi times my slant height, which was 10.6. So that means that I take the 21.2 and multiply it times this 10.6 up here, and then times a half. Wow, that was a nice perfect number. 112 pi. I messed up. This is not my slant height. That's my radius. My slant height is 16. Let's try that again. All right, so we have 0.5 times this 21 up here times 16. There we go. Now it's right. So this is 169.3 pi, or 531. Let's say 532.0 meters. This is lateral surface area, so squared. Find the surface area of a sphere if the circumference of the great circle is that. Okay, so we know what the circumference is. Circumference is 2 pi r, and we need to know what the radius is. So if my circumference is 43.96, to find my radius, I have to divide by 2 pi on both sides. This cancels and this cancels. So that means that I do 43.96 divided by 2 pi. So let's say about 7. All right, surface area for a sphere is 4 pi r squared. So we're going to square that number times 4. So it's 195.8 pi, or 615.1. What is this? Centimeters squared. Find the amount of leather needed to cover a ball 22 centimeters in diameter. So surface area of a sphere. Which means that my radius is 11 centimeters. So my surface area, 4 pi r squared. So 4 times 11 squared is 484 pi, or, because if you bring that to a fabric shop, they're going to have no idea what 484 pi is. But you can tell them that you need 1,520.5 square centimeters of fabric. Actually, they do yards, but still, same thing. Olivia prepared a chocolate cake in the shape of a square pyramid. That's impressive. Which has a base and slant height of 6. A base and slant height of 6. She wants to sprinkle chocolate flakes over the lateral faces of the cake. Find the lateral area of the cake. All right, so we have a square pyramid. I'm not very good at drawing pyramids, so sorry ahead of time. Each of the sides is 6, and then the slant height is also 6. And we have to find the lateral surface area, which is half the perimeter of the base times your slant height. The perimeter of my base, they're each 6 inches long, and there are 4 of them, so 24. So that means my LSA is half of 24 times 6. Which half of 24 times 6 is 72 inches squared, so 72 square inches. Find the amount of glass needed to make an aquarium 36 inches in length, 18 inches in width, and 20 inches in height. The bottom base is made from glass, but there is no top. So what you're basically going to need is an LSA plus 1 base. Because normally for a whole surface area, you do LSA plus 2 bases, but the top of an aquarium isn't made of glass, otherwise you wouldn't be able to feed your fish or get them in there. So it's your LSA plus an area of your base. So that means that we will have perimeter of your base times your height plus the area of your base. So the perimeter of my base is 18 plus 36 plus 18 plus 36, which is 108. And then the area of my base is 18 times 36, which is 648. And then this right here is my height. So I would need my P, which is 108, times my height, which is 20, and then I'm going to add in 648. 108 times 20 is 2160. Add in 648, which is 2808 inches squared. Find the lateral area of a triangular prism with a right triangular base. So wait, we have a right triangular base of a triangular prism. looks like that. Find the lateral area with legs that measure 2 and 3 and a height of 7 feet. To find the LSA of a prism, you need the perimeter of your base times your height, but we don't know what our hypotenuse is right here. We don't know what this is. So we've got to find that, which means we have to do 2 squared plus 3 squared is equal to our height squared. So, and you take the square root of all of that. So our height is the square root of 2 squared plus 3 squared, which means our height is about 3.6. So the perimeter of my base would be 2 plus 3 plus that 3.6. So plus 2 plus 3. 8.6. So we have 8.6 times our height, which is 7. So times 7. That gives us 60.2. And this is feet squared. Find the surface area of the prism. We're going to need the perimeter of our base for that. And we don't know what the height of this triangle is, that side there. So we need x squared plus 6 squared is equal to 10 squared. Subtract 6 squared from both sides to get 10 squared minus 6 squared. Take the square root. And then we find out square root. It's 8. So this is 8 right here. All right, so my surface area is the perimeter of the base times the height plus 2 times the area of your base. So I'm going to need the perimeter of my base, which is 6 plus 8 plus 10, which is 24. And the area of my base, which is half of 8 times 6, which is 24 also. So my surface area, because this is my height, is 24 times 20 plus 2 times 24. 24 times 20 is 480. And 2 times 24 is 48. So add 48. And it's 528 square units since we don't have units. All right, a hexagonal pyramid, and we have to find both surface areas, which means that we will both need the perimeter of the base and the area of the base as well as the height of this pyramid. So we got to find several things. The perimeter of the base is the easiest thing because they're each 12 inches long, and there are 6 of them. So that's 72. Now the area, we need to know our apothem to do that, which means we got to go from this middle down here. This piece is 6. We need to figure out this piece. We need to know this angle so that we know what trig or special right triangle formula to use. Since this is a hexagon, our central angle is 360 divided by 6, which is 60. That is half of the central angle, so that angle is 30 degrees. So we have a 30, 60, 90. And we're going from the short side of our triangle to the long side to get the apothem, which means all we do is multiply times the square root of 3. So my apothem is 6 square roots of 3. So my area of my base is half the apothem times the perimeter. So half of 6 times 72 is 216 square roots of 3. And then we also need to do our height. All right, so that means that it will go from this top all the way down to the center, and it can go over there. Now we already know how long this piece is. We just found it. That's our apothem. So it's 6 square roots of 3. And then our hypotenuse is 13 because that is our slant height. So to find our height, it's h squared plus 6 square roots of 3 squared is equal to our slant height squared, which is 13 squared. I'm going to subtract the 6 square roots of 3 squared from both sides to get 13 squared minus 6 square roots of 3 squared, and then square root all that. So my height will be square root of 13 squared minus 6 square roots of 3 squared. So it's 7.8. And then I realized you don't need your height to find surface area. You need your height to find volume. Oh well. Well, now you know how to find the height. Sorry. Your LSA is half the perimeter of your base times your slant height. So half of 72 times 13, which means it's 468. This is inches squared. My total surface area, or my surface area, is my lateral surface area plus the area of my base, which is 216 square roots of 3. This right here is your unrounded answer, or 468 plus 216 square roots of 3, which is 842.1 square inches. Find the surface area of the hemisphere. So remember that's basically half the regular surface area of a sphere, but then you need to add in the bottom, that base on the bottom. So it's 2 pi r squared plus the area of my base. So the area of my base is the area of a circle, which is pi r squared, which means it's 121 pi. So my surface area is 2 pi 11 squared plus 121 pi. 2 times 11 squared is 242. So my surface area is 363 pi, or 1140.4 square inches. All right, now we've got similar figures. These are areas, so this is actually from the last test, but of course you would do surface areas the same way. We have a two-dimensional surface area, and the smaller one is the one that we're trying to find, so it needs to be small over big. So 169 over 296, 169 divided by 296, math, inner. Oh, that's as reduced as it can be. And then to get our regular scale factor, you would take the square root of that. So the square root of 169 is 13. I don't know what the square root of 296, maybe 16? Ooh. That's 17.2-ish. Okay. So it's that. And then you would do 28 times that 13.7.2. So 28 times 13 divided by this number. So it's 21.2 feet. It's one-dimensional, remember, it's just a height. Find the slant height of a cone with the radius of 4 centimeters. Always do better whenever I'm looking at it. With a radius of 4 centimeters and a surface area of 48. So surface area of a cone this problem is actually easier to do if you use the formula off of the formula chart, which is pi RL plus pi r squared, which is just half the perimeter of the base times the slant height, and then you add in the area of the base. It's the same formula. It's just going to be easier to do this way. So my surface area is 48 pi. My radius is 4. Alrighty, so we have 48 pi, and then 4 pi times my slant height plus 16 pi. I'm going to subtract 16 pi from both sides, so 48 minus 16 is 32 pi. It's equal to 4 pi L. Then divide both sides by 4 pi. Those cancel, my pi's cancel, which means my slant height is 32 divided by 4, which is 8 centimeters. Slant height is just a line down the side, so it's one-dimensional. Find the height of a rectangular prism if it's surface area. So surface area for a rectangular prism is perimeter of the base times the height plus 2 times the area of the base. But this is a rectangular prism, so my surface area is length times width. We're going to call that length, not slant height, times height plus 2 times, oh wait, no, perimeter is not that. Perimeter is 2 times your length plus 2 times your width times your height plus 2 times my area is length times width. There we go. Okay. So if my surface area, if my surface area is 228 and the base has a length of 4 centimeters, so it says length, so 2 times 4 plus, and a width of 9, and then times the height, plus 2 times, and my length is 4, and my width is 9. All right, let's clear some of this up. 2 times 4 is 8. 2 times 9 is 18. 2 times 4 times 9 is 72. Let's go ahead and subtract 72 on both sides. 228 minus 72 is 156. Eight plus 18 is 26. Then divide both sides by 26. So 156 divided by 26 is 6. So my height is 6 centimeters. All right, find the volume of the prism. That's super easy. You actually, anytime it's a rectangular prism, you just multiply these 3 numbers together is what's going to end up happening. But volume is technically area of the base times the height. My area of my base is 12 times 10, and then my height is 3. So see, you multiply them all together, which means that my volume is 360 inches and volume is 3-dimensional, so cubed. Find the volume of the trapezoidal prism. Well, as you saw, we're going to need the area of our base, which is half my 2 bases added together of my trapezoid, so 12 plus 6, times the height of my trapezoid, which is 4. So half times 12 plus 6 times 4, which is 36. All right, so my volume is the area of my base times my height, which this right here is the height. So 36 times 9, which would be 324 cubic feet. A rectangular block of cement is made by pouring cement into a mold with dimensions of 12 by 10 feet by 6 feet. What is the volume of the block? Again, multiply them all together. 12 times 10 times 6. 720. I thought we just did that problem. Didn't we just do a 720? Well, I guess I'm wrong. All right, so volume is 12 times 10 times 6, which is 720. What is this? Feet, cubic feet. The base of a right prism is an equilateral triangle with side lengths of, okay, equilateral. All a right prism means is that it's not tilted. So we would have an equilateral triangle with side lengths of 9 centimeters. Oh, it's not tilted. That. The height of the prism is 6 centimeters. And of course, all of these are the same. Find the exact volume. So we're going to have to find the area of my base. You could use regular polygons if you want to find the apothem. That's one way, or you can use Heron's formula. I prefer Heron's formula. 9 plus 9 plus 9 divided by 2. $13.5. So the area of my base is 13.5, and then 13.5 minus 9, and we're going to cube that. You should really do it for all 3 sides, but I had showed it on a previous problem where if it's 13.5 minus 9 times 13.5 minus 9 times 13.5 minus 9 for all 3 of my sides, then it's just 13.5 minus 9 cubed. So I'm going to put all this in the calculator. 13.5 times 13.5 minus 9. And we're going to cube you. So my big B is 35.1. So my volume is just the big B times my height, which we already know what our height is. So it's 35.1 times 6, which is this times 6. So 210.4, what are my units? Centimeters is this volume, cubic. Okay. And then a right prism has a regular hexagonal base. The side of the bases are each 8 inches long, and the height of the prism is 10 inches long. Find the exact volume. Fortunately for this one, there is no Heron's formula, so you're going to have to use regular polygons. So we have a hexagon. We know that each side of the hexagon is 8 inches, which means this is 4 inches. We need to find our apothem, and we're going to need to know what this angle is. It's going to be 30. My central angle is 60, and when I divide it by 2, it's 30. So that's going from 4 is my short side to my long side, which means my apothem is 4 square roots of 3. So the area of my base is half my apothem times my perimeter, which I haven't done yet. So my perimeter is 8 inches times 6 sides. So that'd be 48. So times 48. All right. Half of 4 times 48 is 96 square roots of 3 for the area of my base. And then it tells you that the height is 10 inches. So the volume is B times H. In other words, 96 square roots of 3 times 10, which means my volume is 960 square roots of 3, or 960 square roots of 3. 1662.8. What are my units? Inches cubed. Find the volume of a regular pyramid with an equilateral triangular base where all edges are 18 centimeters long. Okay, so the volume for a pyramid is 1/3 the area of the base times the height. We know the height. Oh wait, do we? Where all the edges are 18. Find the volume of a regular pyramid with an equilateral triangle base where all the edges are 18 centimeters long. Oh, all edges. Okay, so that includes the height as well. So this is the height also. But we also have an equilateral triangle where they're all 18. So I'm going to use Heron's formula to find the area of my base. So my S is 18 plus 18 plus 18 divided by 2. So 18 times 3 divided by 2 is 27. So the area of my base is the square root of 27, and then 27 minus 18 cubed. So square root of 27, times 27 minus 18 cubed. And the reason it's cubed is because there's 3 sides, so there's 3 of those, because it's an equilateral. So the area of my base is 140.3. So my volume is 1/3, 140.3, times my height, which is also 18. So times 18 divided by 3. My volume is 841. I made a mistake, and it's because I didn't draw it. This 18 is not my height, that's my slant height. So if I make a pyramid and I say all edges, that means this edge. So that's my, that is not my height. That is my, it's not even quite a slant height. It's actually the edge. So in order to find my height, I'm going to have to basically go like this. Well, this right here is going to be half, which is 9, and then my hypotenuse is 18. So I'm going to have to do height. Height squared plus, plus 9 squared is equal to 18 squared. So then I want to subtract 9 squared from both sides, which gives me 18 squared minus 9 squared, and square root that for my height. So square, not alpha. Square root of 18 squared, not p, 18, minus 9 squared. Not -1 squared. There we go. 15.6. So my volume is this times 15.6. So times 140, I need to come up here. There you are, I missed you. Enter, and then divide that by 3. So 728, basically 729. What is this unit? Centimeters cubed. All right, the base of a right prism is a rhombus with diagonals measuring 10 and 24. The height of the prism is 24. Find the volume. Okay, so we have of a prism, base times height. It tells you what the height is right there. So we need the area of my base, which is a rhombus. So that's half your 2 diagonals multiplied together. So half of 10 times 24, which is 120. Yes. So my volume is 120 times 24, which is 2880 cubic feet. Oops, I put squared. That's supposed to be cubic. All right, a silo is a farm building composed of a hemisphere and a cylinder, both with the same radius. The silo pictured below must be filled for the farmer to make a profit. The radius of the silo is 10 feet. What is the exact volume of the silo? So we need the volume of a hemisphere, which is going to be half of a sphere, which is 2/3 pi r cubed, and our radius is 10 cubed. So that's the volume of our hemisphere. Then the volume of our cylinder is big B times h, which my big B is a circle, the area of a circle. So pi r squared, and then times the height, which is 20. All right. So we have 2/3 times 10 cubed. That gives me 0.7 pi. And 10 squared times 20 is 2,000 pi. So the volume of my whole thing is the 2,000 pi plus the 666.7 pi. So plus 2,666.7 pi, or let's go ahead and multiply that times pi. 8,377.6 cubic feet. Our last problem, it says a cylindrical tank has a diameter of 12 inches, in with 20 inches of water. A piece of iron is submerged in the water. Level is raised to 6 inches. So this is what it originally is. So this is 20, right? And then it goes up to 26. What is the volume of the piece of iron? All right, so you need the volume with the 26 inches of water. So the area of our base is pi r squared. So pi times 6 squared times the height, which is 26. And then we're going to subtract out the original volume of the water. So that's pi 6 squared times 20. All right, so 6 squared times 26 is 936 pi. And then 6 squared times 20. Oh no, my calculator froze. There we go. Is 720 pi. So if I do 936 minus 720, I get 216 pi. And then we have to multiply that times pi to get our real one, or our rounded one. 678.6, and what is this? Inches, so cubic inches. And we are finally done with our review.